Unit 1, Geography Skills. This coincides with Chapter 1 of the 2020 Rubenstein text. As you go through the notes, the common pattern will be to list I can statements, and at the end of your notes, you will have to answer those I can statements, which will be practice for the FRQ writing, which is going to be half of the AP exam question content. The other half of the AP exam will be multiple choice. We will practice both multiple choice and FRQs on a daily basis throughout the note process. The content for these 4 key issues in the textbook are as follows. You will not be making a template. Your content objective, today we're going to identify the key types of maps and different types of spatial patterns and relations portrayed in maps. In doing so, 1. Define geography and human geography and explain how the why and where are basic questions and are crucial to understanding spatial patterns. 2. Define a cartographer and cartography. 3. Explain why maps are the primary tool of geographers. 4. Describe the history behind early forms of geographical studies. 5. Explain differences between early maps and contemporary maps of today. And 6. Explain how a reference map is created with data to illustrate spatial patterns. Skip that. Physical geography. Physical geography is based on the landscape. There are 4 spheres. You have your lithosphere, which is the crust of the earth or the topography of the earth. You have your atmosphere, which is the sky or our Milky Way. The hydrosphere, which is our water systems, and the biosphere, which is the living matter on earth. Human geography is different. We are looking at spatial patterns, spatial differentiation, and based on the organization of human activity. The why and where are essential questions of human geographers. Think of where as the physical geography. Where exactly is it located? In Chapter 1, you'll talk about site and place and location. And when you talk about site, place, and location, that will help us understand the where. Whereas human geography is the why. It's explaining the impact of human behavior. And the why and where will help us understand the basic questions to understand or to analyzing spatial patterns. Geographers, when we look at the father of human geography is Eratosthenes. He began to look at where things are on Earth's surfaces, and he asked just the where are the activities and the locations or the places or the sites, and then why are they found there? Do humans modify the earth or do they adapt the earth? And if so, how do they do it? Du Bois began to ask a more, now Forsberg, which is another text, they begin to ask a more modern approach, and they ask why are some things found in certain places but not in others? So that why digs a little bit deeper, more critical analysis of human impact on Earth. And then equally important is how do the characteristics of a particular place shape what happens and to what extent. Again, the idea of explaining spatial pattern is crucial. Making connections to your analyzing your own landscape, local landscape. We will come back to these questions and you should submit them via Schoology. All right, let's talk about the origin of human geography. According to Greek language, geo means earth, graphy means to write. So the quick thing I want you to think about is how do geographers describe where things are and what might be their basic tools. When we look at tools, the first tool we're going to take a look at is a map. maps are two-dimensional, so they're a flat surface that's extracted from the Earth. Cartography is map making. A cartographer is a mapper or a map maker. There are two types of maps, or two purposes of maps, rather. One is a reference tool. That is going to tell us the location, as already mentioned, location of Earth, or it's going to talk about place a specific point on Earth. It's going to talk about space, referring to the physical gap between points on Earth. And again, that will be a reference tool. And the communication is going to describe the why. It's going to describe human activity in reference to the physical features. A map can be an abstract representation of Earth. It uses a scale. And a scale we'll talk more about as we get further on in geography skills. But a scale is just a relationship between a portion of Earth being studied and the Earth as a whole. And this helps accommodate the understanding of that communication of Earth. A map helps us understand spatial distribution, the arrangement of objects or phenomenon, which are also activities. The earliest maps that we look at, they're just, again, looking at the space, so the distance between point A and point B. The first to coin, the father of geography, as I already mentioned, Eratosthenes. Improvements were made by Ptolemy, and we'll take a look at some of them. He was the first to decipher that the Earth was round. And then he also made advancements beyond Europe. He advanced beyond the Chinese and Islamic contributors to cartography. Map making was a revival with the Italian Renaissance in the 15th century. First maps that we look at, we can see with the Polynesian SIG chart. Again, they are looking at just the gaps of space and denoting the important natural landscape of the Marshall Islands in the South Pacific Ocean. And they're using a natural habitat of the biosphere, palm strips, to illustrate through this model of their spatial understanding of their land. When we look at other cartographers, here are significant cartographers. We'll take a look at some of them. For the test, I'll try to highlight the ones you need to know. For surely Eratosthenes, Ptolemy are key contributors. As I already mentioned, the father of geography, Ptolemy, advances that the Earth is round and encompasses more than Europe and takes into account Chinese and Islamic cartographers. And then we'll talk about a few more here throughout the notes. When we look at Ptolemy, again, it shows us the Earth is round. We have a map that goes well beyond the Roman Empire, but we also see that it has a bias. The Roman Empire is at the center of the world. We can take a look at Eratosthenes, and again, his world would derive of mostly the three continents as we know them today, with Africa, the African continent, the European continent, and the Asian continent. Other contributors are Chinese cartographers Yao Gang and Piao Zhao. Piao Zhao is known as the father of Chinese cartography. He was building upon Ptolemy's long neglected work, and he began to advance cartography of the Eastern Hemisphere. Al-Idrizi is a Muslim cartographer, and he prepared a world map and a geography text in the 1100s. We see a map of Al-Idrizi, again building upon Ptolemy's map, an emphasis on the Eastern Hemisphere and Southwest Asia. All right, and then we have Ortelius. He was a Flemish cartographer. He created the first modern atlas. Contemporary map making is a shift from a simple tool that measures space of locations and sites to a more complex geographical communication tool that analyzes phenomenon. Some of the maps that we'll use throughout the year, again, we'll look at the spatial patterns. Remember, space, the gap between point A and B. And when we look at first a thematic map, it looks at statistics. Those statistics can come in different projections, which we'll talk about later. But thematic maps will show us statistical data and the distribution, the arrangement of that statistical data. Choropleth maps are going to be the more common maps we use. They're going to show value of data. So they'll show a range, and that range is found in the key. And you can see in the key in the bottom right, usually goes from a light color to a darker color, showing the value of the data. The third map is a cartogram map. In this map, the size of a country is based on the population, as you can see with the map to the right. A dot matrix map will show us the amount of data. The larger the dot, the more data, or the larger amount. The smaller the dot, the less amount. Topographical maps are going to be used to analyze the landscape. Oftentimes they'll use the elevation that's above the earth and also below the oceans. What kind of map is this? All right, if you said choropleth map, you are correct because it shows a value of data ranging from 6,040 all the way up to the dark color of 191,504. And what kind of map best fits this map? All right, if you said dot matrix, you're correct. The larger the dot, the more data, and the smaller the dot, less data. All right, census data can be used as a reference map. Census data is used to collect information of voters in a city or a neighborhood, and it also collect other information such as voting age and residents per household. And this will be used to create a choropleth map. Spatial patterns in choropleth maps. We can see the spatial patterns of secondary schools. It shows the majority of the countries have less than 70%. Well, we can see the lowest percentage of secondary schools found in sub-Saharan Africa, right in the center of the screen. And we can also see that the darker countries of the northern hemisphere, primarily of both North America as well as Europe and Russian Federation, and then outliers would be Australia and New Zealand, and then also parts of South America, where they have 96 to 100% attending secondary schooling. We can look at spatial patterns with choropleth maps again. In this case, the ethnic distribution of neighborhoods in Singapore. We can see that ethnic Chinese residents are the majority across most of the city, while the ethnic Malay, which is the top one, we can see that they're the ethnic Malay. Let me make sure I find them. Sorry. Again, when we look at the city, we can see that the Malay and ethnic Indian, South Asian Indian population comprises about the same within the city. And they're also found in peripheral neighborhoods, so outlining neighborhoods from the actual city. So if we look at the Chinese population concentrated in the city, most Malay and most South Asian Indian population lies in the periphery or outlining areas of the city, of Singapore City. Again, make sure to answer these questions in your notes. All right, we'll skip this. Continue with key issue 1. Content objective. Describe spatial patterns presented in maps and in quantitative and geospatial data. To break down that content objective, your I-CAN statements are: identify and define contemporary and analytical tools, including remote sensing, geographical information systems, GPS, also known as global positioning satellites, and GIS, also known as geographical information systems. 2. Compare and contrast how remote sensing, GPS, and GIS are used as contemporary geographer tools. 3. Apply your understanding of GPS and GIS and explain how it's used for personal, government, business, and other organizations to handle real-life problems of today. GPS is a mathematical location. So in other words, it's synonymous with an absolute location. It has definitive coordinates. Those coordinates pinpoint an exact location or an absolute location. The GPS has 3 elements. They have 24 satellites that orbit the Earth, and they have tracking stations that monitor and control the satellites. And then they'll have a receiver, which can locate at least 4 satellites at any particular time. And those satellites will have information that discusses the distance from the satellite to the point on Earth. It will also calculate the mathematical location. Some of the applications of GPS. It can give you turn-by-turn directions, as you see in most vehicles. On your cell phone, you can see that it gives you GPS in your Google Maps, and it will tell you, pinpoint the exact location where you are standing. It will be a navigation aid for pilots and ship captains and other navigation or terrain vehicles. It provides location for social media, as I already mentioned. GIS. GIS is an information system. It captures. GIS is usually a computer system, so it's a computer software system that it will capture information, it will store it, it will usually quantify it, or it will aggregate the data, so put it into categories. When it's put into categories, then you can bring out different categories you want to analyze, and you can make queries. And then you can also display geographical information, and this information can be stored as layers. And what you do is you create a mashup map with the layers you want to look at with this GI information. So it's important that you understand the data is stored in layers, or also known as aggregating data categories. The layers can be overlapped, they can be compared and show relations, as we saw in the previous notes with the choropleth maps of ethnic distribution of Chinese, Malay, and South Asian Indian in Singapore City. Those would be 3 layers that they used from a GIS system. But they can also add layers of topography, such as roads, rivers, locations of schools and zones, city planning, zoning, ordinances, or laws. There are many layers. Again, think of a multitude or a plethora of layers that they can be used, because these GIS systems can be quite large and extensive storage bases. And again, the data is used to create overlap of maps, which are called mashup maps. All right, here shows GIS and the overlapping of the 4 maps. You will not have to know for the test the vector and raster, but if you want to know more information on how GIS is used, the vector is related to points. So we're looking at those satellites, finding receivers that find exact points for intersecting lines. That usually are on the grid system, lines of longitude and latitude, or they could be highways or major streets. And then the raster information just gives information about the landforms. All right, there's also photogrammetry. Photogrammetry is a new form of contemporary tool, and this is using the drone to record absolute locations on Earth, as well as surfaces. It could be regional surfaces, so relative locations. Let's take a look at combining GIS and GPS technologies. In real-time call centers, again, a social institution or a government institution that will help route police or fire or ambulance or any other emergency responder to a location with the shortest travel time. Geospatial and geographical data, also geographical information systems, they can use census data and create satellite imagery, and it can help us better understand the location for personal businesses, analyze where and why, the why and where is it located. It can look at organizations, for-profit locations, non-profit organizations, and again answer the why and where, and then government decisions, as we saw with first responders or emergency responders. And again, the GIS and GPS are the geographical information tools that are communicative. They're used as communication, helping define real-life problems. And we can see with Google Street Mapping, and again, this shows the the use of both GPS and GIS within the points of Google Street Mapping of every city. All right, another, well, going back to the GIS and the overlapping of their maps into a choropleth map, again, we can take a look at the distribution, and then we can take more information from the GIS and look for equal opportunities across the ethnicities. So again, we can take that information, and through GIS we can continue to create more overlaps, and then we can also take information and look at the topography and see that if that has interplay with analyzing this social phenomenon of ethnic opportunity in Singapore City. We can look at the Twin Cities, and we can look at spatial patterns and decisions. When we look at the metropolitan school district enrollment, we can see the percentage change of schools. A lot of change is happening in the outlying areas, and we can also see that we've seen a lot of loss of students in the urban centers such as Minneapolis and St. Paul, minus some enclaves in Minneapolis and St. Paul. So as a general rule of thumb, we see suburban districts growing, and then we might want to look at, take a look at more GIS information such as household income, and maybe we could better understand household income and how that plays into the change and growth of education. We could look at topography as well and see if that has any interplay, or we could look at access to mass transit systems. We could overlap data to help understand this phenomenon of intra-regional migration of students to suburban schools. GIS also is GIS science, so that's just taking data and satellites and other electronic information technology. So again, geographical information science is just the science of GIS. Collecting data, remote sensing, that's extracting information off Earth. Usually it's from a high balloon or an airplane, and then it will orbit Earth, and it's often used for desolate areas of the Earth where no other way of extracting information is possible. All right, and again, collecting data. We're looking at sensors scan the Earth, a computer assembles the information. It's then stored in pixels, which are rows and columns, and then it's based on radiation, oftentimes the heat of the Earth's surface, where they're extracting this information with remote sensing. All right, again, in conclusion, respond to the following 4 questions. Applying GIS in another way. This table shows the collection of, well, it shows the customers by zip code and the transactions and the amount of the transaction. So we can analyze this and have a better understanding for this particular store of what location might be most prosperous within the area zip code based on the number of transactions and the gross profit, the amount of that transaction. So if you're analyzing the data, what zip code would you place your store? Well, hopefully everyone said zip code 43286. All right, go ahead and take a look at this. Make sure you understand today's lesson. And as always, circle where you're at with understanding each of these 3 categories to the I CAN statements, and also make sure that you answer the I CAN statements with content from the notes and also your Chapter 1 of the 2020 Rubenstein text.